The next method we're going to study is method 2 for multiple fractions. Now, for complex fractions with multiple fractions in the numerator and denominator, we still could use method 1 by adding the fractions in the numerator and adding the fractions in the denominator and then multiplying by the reciprocal. But we know from previous lessons that adding fractions with unlike denominators is a long and annoying process. So by using method 2, we can avoid that. So let's go look at this. See, I have on my first problem, I have two fractions. So in order to make this into one fraction so that I can multiply by the reciprocal, I would have to get a common denominator, xy. I'd have to multiply um, any the numerator and the denominator by any missing factors. Then I'd have to combine like terms, and that seems like a whole problem in and of itself. I definitely don't want to do that if I can avoid it. So method 2 provides you with another method that works very simple for these problems instead of having to add fractions, which are yuck. No one wants to do that. So the steps are: find the LCD of all fractions. Now that's talking denominators in the numerator and denominators in the denominator. All of them need to have, you need to find the LCD of all of them. Then what you're going to do is multiply every term in the numerator and the denominator by the LCD. The reason you're allowed to do this is because of that fraction bar. Because there's a secondary fraction bar, you're allowed to multiply the numerator and denominator by anything you want. Now, some students want to take this really cool method, which after we do a couple problems, you're like, this is awesome, and apply it to some of the previous sections of adding and subtracting fractions. This only works for complex fractions because of that second fraction bar. Okay, you have fractions in the numerator and fractions in the denominator. So don't try to apply this method to anything other than complex fractions. The third step is reduce. So let's go ahead and try. My LCD for all denominators, I'm looking at x, y, and 5x cubed y. I have to find every single base independent. I have a 5, I have some x's, and I have some y's. The greatest exponent of 5 is 1. The greatest exponent of all of the x's is 3, and the greatest exponent of all the y's is 1. So we have 5x cubed y as our LCD. Now that I have 5x cubed y as my LCD, I'm going to do step 2. Step 2 says multiply every single term in both the numerator and the denominator by the LCD. The reason I'm allowed to do that is because of that red fraction bar. So I'm going to write it on every single fraction. 5x cubed y. I'm multiplying out to every single numerator in both the numerator and the denominator. So I'm allowed to do that again because of the red bar, and now I go back and reduce each fraction, and in one step it's going to make it into one fraction instead of fractions over fractions. So on the first fraction, so we have 3 times 5x cubed y over x. Notice that the x in the denominator and one of the x's in the numerator divide out, and that leaves me with 15 x squared now y. Then there's a minus sign in the problem, so we're going to keep our minus sign. Let's reduce the second one. Notice the y in the denominator and the y in the numerator divide out. If you've chosen your LCD correctly, the denominator should divide out every time. And I'm left with 1 times 5, which is 5x cubed. In the denominator, the 5's divide out, the y's divide out, and the x cubes divide out. So all I'm left with is 6. Now, looks like that numerator can factor, so I'm going to try to factor that numerator. I can take out a 5x squared, and that leaves me with 3y minus x over 6. Doesn't look like anything divides out, so this answer is our final answer, but that means also because nothing reduced, the previous one would also work as a solution. And that came out fairly simple without having to find any common denominators and add the numerators and then proceed with the problem. So this is a much nicer method. If it seemed a little confusing, let's try a couple more. Please don't discount this method just yet. So on the next one, I'm looking for the LCD of all denominators. The denominator x, 2, 7x, and 14xy. Be careful, 14 is a complex number, which is 7 times 2, xy. So I need all of the unique bases. So it looks like I have 7 as a unique base, 2, an x, and a y. Okay, what is the highest exponent 7 has? Well, 7 to the 1. The highest exponent of 2 is 2 to the 1. The highest exponent of x is x to the 1 and y to the 1. So my LCD is just 14xy. Now, because of this red bar right here, that allows me to multiply anything I want to the numerator and the denominator. So I can multiply 14xy to every single numerator and then reduce. Every single denominator should divide out nicely. So I have my red fraction bar. And on the first fraction, notice one of the x's divides out nicely, and I'm just left with 1 times 14y, which is just 14y. The minus in the original problem continues to come down as a minus. On the second fraction in the numerator, we have 1 times 14xy over 2. The 14 and the 2 can divide out to 7, so that's minus 7xy. On the denominator, the 7 and the 14 divide out to 2, and the x copies divide out, and I'm left with 2y times 5. Well, 2y times 5, that's 10y. On the second denominator, all of the factors divide out, and I'm just left with 5. Now I think I can factor that, so I'm going to go ahead and try to factor that one. I have a 7y in the numerator, which leaves me with 2 minus x. In the denominator, I can factor out a 5, which leaves with 2y minus 1. Nothing divides out, so that's my final answer. But because nothing divided out, I can have either this one or this one. Now, if something divided out, then I must divide it out, and that would be the only answer. But because nothing does, either one will both be acceptable answers. On our next problem, we have some parts that are whole numbers. So the first thing I want to do is create those into fractions. So I'm going to put the 2 over 1 and the 4 over 1. So now that everybody's a fraction. And I want to look for the LCD. So the LCD between 1, 3x, 3x squared, 1, 3x, and x squared, it looks like the unique factors are 3 and x. The highest degree 3 is ever raised to is 1, and the highest degree x is ever raised to is 2, so that gets me 3x squared. Now I am going to multiply 3x squared to every single numerator, including the whole number 2 and the whole number 4. So I'm going to multiply by 3x squared on every single term in the numerator and every term in the denominator. Please don't be lazy. Go ahead and write it out on every single one of them. It's going to help you quite a bit. So we have this red fraction bar that I'm going to bring down. In the first fraction, 3x squared times 2 divided by 1 is 6x squared. On the second fraction, the 3's divide out, and one of the x's divide out to give me minus 7x. On the last fraction in the numerator, all of the factors cancel out, and I'm left with just minus 10. In one simple step, I've got my numerator to be just all whole numbers. On the denominator, I have 3x squared times 4 divided by 1. That's 12x squared. The 3 and one of the x's divide out on the second one. That leaves me with 8 times x, or minus 8x. On the last one, just the x squareds divide out, and I'm left with minus 15. Now, it looks like these might factor, so I'm going to try that. On the 6x squared minus 7x minus 10, I'm going to try 2x and 3x and 2 and 5. Now, I don't ever want to put the 2 and the 2 next to each other, so I'm going to try instead 5 and 2 this way. When I multiply across, that gets me 4x and 15x. That's not going to get me 7, is it? Okay, I tried. It didn't work. Let's try again. Switching those around isn't going to help. Let's try 6 and 1. And 2 and 5. That's going to get me 5x and 12x, which one of each sign is going to get me a negative 7. So in the numerator, this factors x minus 2 times 6x plus 5. In the denominator, I still have to do some more factoring. So because there's a 6 and a 5 here, instead of picking 3 and 4 first, let's try this just to see if we can't match that up. So I'm going to try 2x and 6x for the denominator. And for 15, I'm going to go ahead and try 3 and 5. So I can put the 5 and the 6 next to each other. It's kind of a little sneaky trick where I'm trying to get these two to possibly divide out. I can't force them, but I can definitely guess and check them. Oh, certainly does. I have a negative on the 18 and a positive on the 10. Okay, so that gets me 2x plus 3 and 6x plus 5. All right, so those 6x plus 5's divided out, and my final answer is x minus 2 over 2x plus 3. You can keep your parentheses, or you don't have to.